Today's lab is a recrystallization method, and when you follow recrystallizations, it's a process of where you take something that is impure and recrystallize it in order to obtain a more pure compound. The first thing you have to do is to figure out which solvent you're going to use for recrystallization. So the only compound we're going to recrystallize today is benzoic acid. So what I have here are two test tubes, both of which contain benzoic acid, which is a white crystalline substance. And the two solvents that I'm going to use is water and ethanol. So typically you put somewhere between 20 and 30 milligrams of your sample in here, and then somewhere between half a mil and a milliliter of liquid, whatever your solvent happens to be. And you always want to stir it. You can't just sit there and see if anything's going to dissolve without some elbow grease. And if you notice, it doesn't appear that much of that has dissolved. You still see a lot of white solid at the bottom of that test tube. So now I want to do the same thing, the same substance, and I'm going to add ethanol to that. And as you can tell, it looks like most of that has dissolved in the ethanol. So what does that mean? Whenever you do a recrystallization, you want to choose a solvent that does not dissolve it at room temperature, and a lot of time in chemistry we call that cold, which really isn't, but we usually say it doesn't dissolve cold or room temperature, but does dissolve hot. So if I'm looking at this test tube where the ethanol dissolved the benzoic acid at room temperature, that would not be a good solvent to use for recrystallization, because I most likely will never get it to crystallize out again if it's soluble at room temp. So what I need to do next is to take my test tube that had the benzoic acid and water, and what I want to do is to heat that up and see if any of it will dissolve at hot conditions. And I'm hoping that most of that white crystalline solid will dissolve. And sometimes, don't be surprised, it may take a while for the dissolution to take place. My temperature of the water bath probably should be close to boiling, and it probably isn't there yet, so that's one reason it's probably taken a little bit more time to dissolve. And we may need to let it sit in here for a few minutes, and I'm going to do that. And as you can see, dissolution finally took place. So again, the reason you go through this process when choosing a solvent for recrystallization, you want to choose a solvent that does not dissolve it at room temperature but does dissolve it hot. Now, since we've decided what solvent we're going to use to recrystallize the benzoic acid, I went ahead and measured out 1.161 grams of the benzoic acid, and this is impure benzoic acid. As you can see, it has kind of a dark color associated with it. So our purpose today is to take this impure benzoic acid, and using water as the solvent, we want that everything else should dissolve in the solvent, including our impure substance. But then, once it starts cooling down, the only thing hopefully that will crystallize will be the pure benzoic acid. Now, it could be that there may be trash. I notice this is fairly dark in color. We'll probably have to go through a hot gravity filtration to use charcoal to purify this. We'll see what happens when we get to that stage. So I'm going to put this on a hot plate, and I have a magnetic stir bar that's in there. And I'm going to add probably maybe 10 or so mils of distilled water. And I will say that it's unusual for chemists to keep track of exactly how much solvent they use, because each time they recrystallize a sample, even if it's the same substance, depending on its purity or impurity, those amounts can vary. So a lot of times we just say that this compound was recrystallized from water or whichever the solvent may be. So I'm going to let that heat a little bit. I want to make sure that it's close to the boiling point. I don't want to go too far and add too much liquid, but I also want to make sure I add enough of that solvent, enough of the water, so that the impure benzoic acid dissolves. And also should mention that when you do a recrystallization, you typically want to do it in an Erlenmeyer flask. You do not want to use a beaker or some other type of glassware. If you use a beaker, you have a lot of evaporation of your solvent because it has such a wide mouth at the top. So you typically want to use an Erlenmeyer flask. And there's different sizes you can use. I chose to use a 125. Could be that I could use something that's a little bit smaller, but I'd rather have something too big than not big enough. And you also want to make sure that you use some type of stirring mechanism. This hot plate has a stirring mechanism with it. That's the reason I use the magnetic stir bar. If you don't have access to that, then typically boiling stones would do the same job. But you never want to heat something in organic chemistry, especially without stirring, because that liquid can grab enough energy from the heat and can shoot out of that container just like a geyser. So you always want to give it something to bump up against, whether it would be a stirring bar or whether it would be those boiling stones. As you can see, it looks a lot more clear. If you take a look, it looks like there's some black material that's in there, but it looks like for the most part, most of the white crystalline material has dissolved. Because it does have this dark color, and I don't know if that's something that is an impurity that I need to remove that dark color. So what I need to do next, I'm going to add charcoal to that mixture, and after it stirs for a few minutes with the charcoal added to it, I need to add something that the charcoal can adhere to. We call that filter aid. I'll let it boil a little bit longer after that, and then I'm going to filter it through a hot gravity filtration. And just to kind of show you what a hot gravity filtration is, I have an Erlenmeyer flask, and inside that Erlenmeyer flask I just have a few mils of water. Whatever solvent you use has to be the same that you're doing the recrystallization in. So I have an Erlenmeyer flask with just a few mils of water, distilled water there. Notice that I have this ring stand with a funnel, and this funnel is stemless because when I'm filtering something, I don't want anything crystallizing when it gets cold in the stem of the funnel. So this is a stemless funnel, and then I've also put a piece of fluted filter paper. So what happens when I take the mixture that has the charcoal and the filter aid and pour it through here, the filter aid should attach to the charcoal, and then that should be left behind in the filter paper, and then the filtrate will contain my purified substance. Now there may be other things that's dissolved in the hot water, but once recrystallization has occurred, hopefully those things will stay in the water. And you want to let that get a little hot. You want this to get warm, because you want this to be warm, because if you pour something hot, into something that's cool, you may lose some of your recrystallized product because it may start crystallizing here before you want it to. Now, what I typically like to do is add, even though it looks like everything is dissolved, I like to add a little bit more solvent. I can always get rid of excess solvent, but if I don't use enough solvent, I can lose some of my recrystallized product. And in this beaker, I just have some distilled water. I'm going to take a pipette and just kind of rinse down the sides of that flask. Because during the process of the boiling, it's very possible that some of that material kind of climbed up the sides of that Erlenmeyer flask. I just want to let that boil a little bit. Because anytime you add something that's not hot to it, that material would like to crystallize out. Because remember, it is only soluble at the hot temperature. So if I add something cold to it, then it will cause some of that to recrystallize. And I can see that here. You can kind of see the cloudiness there where some of that has crystallized out. So I'm going to let that heat back up to the boil, and hopefully all that will be soluble. I'll add the charcoal, and then I will add the filter aid, and then we'll filter it through hot gravity filtration. How much should you do this? You know, it just kind of depends. Again, I kind of like to err on the side of having too much solvent than not enough. So we'll let that go into solution, and then we'll add the charcoal and the filter aid to that. So now you can see that all the white, the cloudiness has disappeared. We still have that dark material that's in there. So what I'm going to do is I'm going to add some charcoal to that, and I don't bother to weigh this out. I probably would add maybe about the end of a spatula, something like this, if y'all can see that. Now, you never really want to add it to this while it's on the hot plate, but you don't want to waste a lot of time and let this cool back down a lot. So typically what I do is I take it off, I add it here, and then I'll put it right back up here and let it start stirring some more. And typically for the charcoal is great for removing colored impurities. Most of the things that have color associated with them in organic chemistry usually have pi bonds, and anything that has a pi bond will adhere to that charcoal and removing the color. So usually let that maybe stir for about 3 to 5 minutes or so. Now again, anytime that I'm heating this, as you're heating this, you're allowing some of that solvent to evaporate, and I want to keep that a little bit at a surplus. So always have my water here, or whatever your solvent is, and then I'm just going to kind of rinse down the side of that. Now if some of my material crystallizes like it did before, no problem. It will go back in solution as it's being heated. Alright, so it's been about 3 minutes, so I'm going to take this off, and then I'm also going to add some of the filter aid. And what the filter aid does is the charcoal will adhere to this, and then when I filter it, I don't have to worry about the charcoal going through the filter paper. The pores of the filter paper are not small enough to keep the charcoal from going through, but if you give the charcoal something to latch onto, then typically no problem. It will be removed when you filter it. I like to do about 2 or so times the amount of charcoal that I used. So that's kind of bad. We're looking at white and white, but I kind of like to use maybe about twice as much of the filter aid as I do the charcoal. So I'm going to do the same thing, take that off, I'm going to add it to it, then put it back up here, let it stir, you know, for a couple minutes, and then at that point we'll move it over to the hot gravity filtration, and then we'll filter it through that hot gravity filtration. I'm going to do the same thing that I did before. Anytime I'm letting this boil for a period of time, I just want to add some of that solvent, in this case water. just to kind of keep that at a surplus. Let that boil for a few minutes, and then we'll do the hot gravity filtration. I should also point out that anytime you add charcoal, and I mentioned that a lot of colored components have the pi bonds that adhere to the charcoal, your organic compound also has pi bonds typically that will adhere to the charcoal. So when you do any type of recrystallization, you will always lose some of your substance that you're trying to recrystallize. That's always going to happen. There's a lot of things that can kind of vary. Did I boil it long enough? Did I need more solvent? Did I need less solvent? There's a lot of parameters that we could change to increase the yield, but whether or not you want to do that depends also on how pure the sample you want it to be at the end of the recrystallization. Sometimes you have to weigh purity against a yield. If I want the sample to be very pure and I'm not so concerned about the yield, I'll follow one method. If I need to clean it up a little bit, but I'm not so concerned that it's 100% pure, then I will use another set of parameters. I think it's been stirring long enough, so I'm going to take this off the hot plate just long enough that I can remove the stir bar, because we never want to lose that. Then I'm going to take this and pour it through this fluted filter paper. This is my hot gravity filtration. And I'm just going to kind of keep it here on the hot plate because I want to keep that hot. I don't want any of my sample recrystallizing. And I can also go and add hot water or water to this and do a rinse of my material that I collected in the fluted filter paper. So I'm just going to let this heat a little bit, because we always want this to be hot that we're pouring through that. It looks like most of the material has filtered through the filter paper. I just want to pull this out and let you see what this looks like here. So all of your filter aid and the charcoal was caught in the filter paper. Again, there is the possibility, more likely than not, that some of your sample has also crystallized on here, has also combined or attached to the charcoal and the filter aid. But again, that's the trade-off we have to in order to purify something that we're trying to purify. What I'll do now is I'm just going to let it boil here with the stirring. And this is the part where we're not always 100% sure of where and when we should stop the boiling process, because when we take this Erlenmeyer flask that contains our sample off the hot plate and set it aside to cool, upon cooling, those crystals should reform. Now, we don't really know how much liquid we should have in there because we don't really know how impure the sample was to start with. So I have a little process that's called, or a technique that's called the test tube test. And what that does, it kind of gives me a pretty good indication of when I should take this flask off, when crystallization should start to take place. The purpose of this test tube test, I take a clean test tube and I take a pipette. And what I'm going to do is I'm going to pull up the liquid. Now remember, the liquid, this solvent, this mixture, has the distilled water in it. It has our sample that we want to recrystallize, hopefully in a pure form, the benzoic acid. The other thing that it can also contain are impurities that dissolved in the hot water, but because they're so small, they'll hopefully will stay in the water even though when it cools back down to room temperature. So I'm going to take some of this out. Now notice that it did not crystallize when I'm pulling it up, and all I'm doing is once I release it into that test tube, I'm pulling it back up and back and forth to see if anything is crystallizing. And if you notice, there's a little bit of cloudiness.
Yeah.
But it doesn't look like it's crystallized to my desire. So what I'm going to do, I'm going to put this back inside here. This is the reason I'm not wasting any material when I do this test, because I can pour this back in there, and whatever wasn't dissolved will now dissolve. So I'm going to let that boil for a few minutes, because I don't want it to crystallize as soon as it comes up in the pipette, which it did not. And I don't want it to crystallize as soon as it hits this, but I want to see a little bit more crystallization than what I just saw. So we're going to let this heat a little bit longer for a few minutes, and then I'm going to check this. Sometimes you just have to periodically check this, and then once we feel comfortable, and I'll kind of give you a picture of what that looks like from the test tube test, we'll take this off, remove the stir bar, stopper it, and just let it cool on its own until those crystals. We're going to take another look at our sample to see if it's ready. It's been stirring at the boil for several minutes. To me, that looks a little better than it did before. Looks like I have more crystallization than I did the first time I tried this. So what does that tell me? That tells me that this is going to crystallize when it gets cooler. And the process of me pulling it back and forth is trying to cool that material. So I'm going to try to pour this back in. That looks pretty good to me. I think that's going to be okay. And if there's some that got stuck here, you can always use the hot water to kind of rinse your pipette back in there. I can do the same thing here. Rinse that back in there so I'm not really losing any material. So I think at that point, we'll go ahead and take this off the hot plate, and I'm going to let it sit on a wire gauze. I'm going to turn the hot plate off, and then I'm going to get paper towel and just loosely stopper this. I'm also going to remove the stir bar, so I don't want that in there. So I'm going to remove the stir bar and then take some paper towel. And then I don't want the solvent to evaporate anymore, so I just want to kind of put that in there, and that will keep the solvent from evaporating. And then hopefully as this cools down, we'll start seeing these beautiful crystals. We can't really do anything now until that completely crystallizes. And as you can see some of the crystal formation at the bottom. We're going to let that sit. It's still warm to the touch, so we really need to let that flask cool and the contents inside to cool to room temp, and then we'll take another look at it and see where to go from there. Now we're ready to do the filtration, and we're going to use a Buchner funnel. You can see we seem to have a fair amount of crystals that formed, and hopefully this will be the pure benzoic acid. To filter something by vacuum filtration, we have a suction flask, and you can tell it looks very similar to an Erlenmeyer flask with the side arm here. This side arm is connected to the aspirator of the faucet. The Buchner funnel has a lot of holes inside it, and then we put a piece of filter paper on the top. That filter paper should fit the Buchner funnel. All holes should be covered. It shouldn't be creeping up the side, so if it's not the right size, you would need to cut to make sure that it does fit. When we turn the faucet on, typically you just turn the cold water on. Our vacuum system doesn't work as well unless we turn both on, but typically you just turn one on. I have a little plastic beaker in the bottom to kind of catch the water to keep it from splattering so much. And I'm going to turn, you always want to turn your faucet all the way on. So I'm going to turn both of those on all the way. Whatever solvent you're using for the recrystallization, you want to use that solvent and wet the filter paper, because if you don't, once you start filtering your sample, you can lose some of that material. So I'm just going to wet it with some distilled water, and you can see quickly how the water is being pulled through there. I like to give it just another push to make sure that there is a good vacuum in place. And then once we're ready, I'm just going to swirl this and pour it all at once in the Buchner funnel. And I also had some chilled solvent in an ice bath. Whenever you filter something by vacuum filtration, it's always a good idea to wash it with cold solvent. If you wash it with room temperature solvent, you do run into the possibility that some of your recrystallized material may dissolve. So you always want to wash it with chilled solvent. And the reason that we want to wash it is that not only what I'm collecting is my pure product, hopefully, but it is possible that in the water there could be some small molecules that are dissolved in that water. But when I filter it, those small particles, those small molecules could get trapped between the molecules of the benzoic acid. So I want to make sure I just wash this a few times with this chilled solvent. I like to pour it back into the flask that I was using for the recrystallization, just in case there's any last traces of the material left there. And you can see how quickly the water goes through that Buchner funnel. Probably about 3 times is good enough. It's important not to disturb that filter paper. If you try to take a spatula and stir something around, you're going to poke a hole in it, then you got to refilter the material. I like to kind of just make sure that it, we use the phrase sucks dry as long as possible. Notice that the filtrate that went through the Buchner funnel is colorless, which tells me I didn't lose anything necessarily. If there's some that did go through, if it's cold, it typically would recrystallize down here, so I'm happy with what I see there. It looks like everything appears to be dry. When you cut off your vacuum filtration, you never want to cut the faucet off first. If you do that, what can happen is that the water can be sucked up through this tubing and come back into your filtrate here. Now, if that were to happen today, that doesn't concern me, because I'm not going to use this anymore. But there's sometimes in this lab that we will use what we collect here, and the last thing you want is it to be contaminated with something else because you're trying to purify it. So when you're done with the vacuum filtration, you always remove the sidearm tube, and then you'll cut off the faucet. What we want to do next is we're going to remove the Buchner funnel, and you can see, you can see the white crystalline solid that's there. What I'm going to do is transfer this to a larger piece of filter paper. Ideally, if we had a drying oven, we could put this in a drying oven for a few days or a few hours and then come back and take a weight and a melting point. What we're going to do today is just go ahead and try to dry it as much as possible. And it looks like pretty much everything came out on top of that filter paper. And so what we want to do is kind of move this and I have to say those are beautiful crystals. So I've removed everything from pretty much from the wet filter paper. What I want to do is just in case that there's any water that's present, and there's likely that there is. I just want to squeeze this between a couple pieces of the filter paper. What that will do will try to remove any moisture that's there. And you can pretty much tell if it is wet because you'll see wet spots on the filter paper. And that looks pretty dry to me. So what I'm going to do next is get a weight, and then I'll get a melting point. When you do a melting point, it's really a good idea to kind of crunch up your sample, and less is more. You don't want to cover up this whole disc that's in the well of the melting point apparatus. These are discs, circular discs that we put one inside the well. We'll make a sandwich, so to speak. I'll take some of the material to determine the melting point of. We'll put that on the disc, and then we'll sandwich it with another one, and then we'll record the melting point. This material is so light and airy, it's a little bit difficult to get it on. Let's see what. Now, this particular Fisher-John melting point apparatus, there is a magnifying lens that we put over the sample. This is a mercury thermometer that we have in here. When you determine the melting point, and we turn it on, and you'll see the light that's shining on the sample, heat is going to the sample, which is going to be recorded as far as the thermometer is concerned, at which point the melting point occurs. You don't want to heat this up too high. Typically, we like to have maybe starting at about 20. And that's not 20 degrees, that's just increments in terms of how much heat's being generated to our sample. Typically you want to start maybe at 20. If you start having changes in temperature that's more than a minute every couple degrees, then you probably want to cut back down, because it's very easy to overshoot that melting point. So periodically what I need to do is just to look through that magnifying glass. I want to record the temperature when I see the first drop of liquid, and keep recording that temperature until it completely liquefies. And most of the time, even with your pure sample, it's not unusual for there to be a range, a melting point range. So we'll kind of keep a check on that to see what the actual temperature is.